Hello, Victor Nudge, the product manager of GitLab speaking here. This is one more very short video of the demo projects, how I explained it a little bit. These are demo projects, they're public now. You can check out the code yourself. But now let's focus on what we have today. I added actually image signing and attestation checking, signature checking into the delivery project. Let me quickly walk through how that happens. But before that, let's take a look at what it means. Basically, GitLab has this amazing direction page and software supply security. And we have quite a few things ready already to support it. And this part is actually to check the box here that we can actually verify the validity of your image within your Kubernetes cluster. So let's see how we do that. Some things happen in GitLab CI where we are building the OCI artifacts and the Helm charts to be deployed to the cluster, and the other things happens in the cluster. First of all, we have a dedicated image that includes the necessary tools, and these necessary tools are basically Cosine, Crane for moving the packages around, Flux CD, JQ, Helm, and kubectl. These will be used throughout this pipeline. Basically, all the jobs here use the image generated in this tools section. As you can see, this is one of them, and this is the other job. And what we do is that in the Flux OCI job, we create the image with Flux push artifact, and then we extract the digest URL of that image in a single call actually, and we log into Cosine and sign the image. Now login happens with the ID token, the OIDC support in GitLab CI, so you don't have to store any long-lived tokens within GitLab. And once the image is signed, we can actually go and tell Flux, this is a Flux Helm release, as you can see, and you can say it to check the provider of this Helm chart using Cosine with a specified secret key. And similarly, we can tell to the related OCI repository to check the image with Cosine. In the cluster, we have everything running, as you can see. First of all, I'm using, let's go back 1 more minute here. Here you can see that I'm using a Cosine key prefix with Kubernetes. This means that this key exists in the cluster. There's a dedicated Cosine command, generate secret key, if I remember well, to generate the secret private public key pair and the password, and you can store it immediately in your cluster as well. And that's why we actually need to run kubectl here as well in order to select the right cluster, after which Cosine will be able to access that cluster using the selected context, and everything nicely fits together. So first, let's see the secret. It's there. This is Cosine key. It has 3 keys. Doesn't really matter. We only need the pub key for checking the signature, and of course the password and the private key for signing itself. And then let's see how it looks like that it's really there. We have these OCI repositories that I showed you before that are meant to be signed. This is the detailed spec. This is what we provided to the Flux manifest that we want signature, and in the status you can see this section here saying that the signature was verified, it was successful, and everything runs as expected, as you have seen actually under the pods view. This closes this short demo. I hope you like it. we can sign both the Helm charts used here as shown and the OCI repository, the OCI images actually. So, and afterwards, Flux will check those signatures in the cluster.